I'm Carrie Mcdougall from NOAA's Office of Education, and today I'm going to be conveying some of the findings we've learned in working with our large spherical display system called Science on a Sphere. But first I want to make sure you all are aware of NOAA. NOAA is the National Oceanic and Atmospheric Administration. It is a federal science agency. We are charged with understanding and predicting changes in climate, weather, oceans, and coasts, sharing that knowledge and information with others, and conserving and managing coastal and marine ecosystems and resources. To conduct this mission, we collect a lot of data. We collect data from ships, from planes, from buoys, from radar, from satellites, from all different kinds of sensors in the water, in the air, on land, and we generate a lot of data. Our challenge is that we have to make this data into something that people can understand and make sense of, and make products that people can make informed decisions with. So that leads me to talk about a beach ball. In the early 1990s, one of NOAA's preeminent scientists, Dr. Sandy Mcdougall, who was dealing with a lot of these global data sets, was thinking, gee, wouldn't it be nice if we had a way to look at these global data sets on an object that matches the data, on a sphere? And so he got a beach ball, painted it white, hung it in his garage, and started fooling around with a projector, seeing how he might be able to use a projector to project onto a spherical screen and how that might work. He started diagramming things on a napkin, as all good scientists do. And fortunately, he found a very talented software engineer who made it all come to reality. And a few years later, NOAA's Science on a Sphere was born. The Science on a Sphere uses 4 projectors to project onto the outside of a large-scale carbon fiber sphere. And in 2003, here's a stodgy government photo of NOAA's Science on a Sphere debut in NOAA headquarters. In 2003, it was ready, an early prototype was ready to bring to other parts of NOAA from its home in Boulder, Colorado, where Sandy was the director of the lab there. And that's Sandy sitting in the foreground looking, for some reason, very forlorn. And I'm in the picture in the middle with my eyes closed, which is that's how you best view Science on a Sphere. And so the first time I saw, this was the first time I saw Science on a Sphere, and I was trained as a marine biologist, and when I saw this and saw ocean currents wrapping around the tip of South Africa, I was struck at how powerful this visual tool is and how we really need to get it into the hands of educators and in front of public audiences. So we started doing that. So as you can see, it's a 68-inch, the standard exhibit is a 68-inch diameter carbon fiber sphere. So it's a large-scale spherical display screen, essentially, large enough for groups to gather around. You can walk around it. When suspended in a dark room and you walk in, it feels like you're an astronaut hovering, looking at Earth from space. So it has quite a stunning impact the first time you see it. It draws people of all ages. There is an inherent compelling nature to this floating Earth image in front of you. As a result, it works very well in museum environments. And so we started working with museums to help them build permanent exhibits around Science on a Sphere. Today, we have over 150 locations of Science on a Sphere around the world, installed in some of the largest, the museums with largest visitors, like in India and China, that have millions of visitors coursing through their doors every day. We have them in planetariums and schools. Some public schools have Science on a Sphere. What a fantastic tool to use in a K-12 environment. We have them in aquariums. Many of the Chinese meteorological labs have them to talk about weather products. So they're used in a lot of different environments. Altogether, these institutions have over 60 million people a year who visit them. So we don't know that 100% of those people see Science on a Sphere, but that's how many people go through the doors of all of the institutions that have Science on a Sphere. So we've had a major growth in the number of institutions with Science on a Sphere. We've also had a tremendous growth in the data sets that support Science on a Sphere. We call it the data catalog. And we have over 500 data sets from various sources, as you can see here. NASA has been a partner from day one with us with Science on a Sphere. They have several at NASA visitor centers, and they contribute a lot of data to the effort. We also take data sets from Science on a Sphere sites. For example, Brian Kennedy from Science Museum of Minnesota, they've contributed a lot of their data sets that they have been producing over the years. We also have a lot of real-time data sets or near real-time data sets, and that's a major asset for this spherical display system. Because we can push real-time data sets without museums having to do anything, it's a tool that once installed, the museum can constantly be on the cutting edge of what's happening on the planet by showing these real-time data sets, and they don't have to buy any new products, they don't have to do anything, it just comes onto their sphere automatically. And we also have 80 narrated movies for auto-run mode, and we're always adding new data sets. So early on, when we first were working with our first 5 museums that got Science on a Sphere, we quickly realized that this tool there's something about it that's inherently engaging and it's powerful, and we have all these data sets. Many of them are extremely complex. You can see one here from NASA. But we don't really know how this is going to work in an education setting. We don't really know how this works. We know how it works with other scientists, and it works well. It helps scientists make other discoveries. But in an education setting, what is it we need to add to this tool to help it be really meaningful in a museum environment or other informal environments? So we started talking informally in the first few years and quickly realized we needed to formalize that relationship. And so we formed a users collaborative network. And now we have members, everyone who has Science on a Sphere, who uses the Sphere for public education is part of the network. We have over 140 member institutions. That's slightly smaller than the number I showed before because some of those institutions don't use their Sphere for public education, and then they're not part of our network. So these are really groups, these are institutions that are really like-minded. They are using the same technology. They largely have the same end goal, which is to educate the public generally on Earth or space science. And they're interested in sharing what they're learning and how best to use the technology. And so it's really been a highly collaborative, sort of open source model users network from the very beginning, and members of that network are here in the audience. And we also have members of the network who are contributors to the data catalog. So you don't necessarily have to have a Sphere, but if you're a major contributor to the data catalog, you're also part of our network. The network meets face-to-face every 18 months for about a 3-day meeting, and we bring everybody together, and we host it at a Sphere location. We move the meeting around so we all get to see different host sites, and we share what we're doing. The basis of this partnership works really well for a federal science agency like NOAA. We are charged with collecting the data, analyzing the data, making the data available, visualizing the data, but we don't necessarily have the public audience at our fingertips. We don't have expertise in interpreting that data for public audiences. Science centers, museums, aquariums, they have that. So working directly in partnership with those institutions makes a lot of sense. That's where the public is going. Those science centers are trusted sources of science information, as has been shown again and again and again. The public trusts science centers and the like more than they trust government entities and scientists for science information. So go to the source, go to the place where the people who are there who can help us interpret that information, and then establish these feedback loops to help us improve the technology. And so that's what we do through the network. So in those network meetings and other webinars, we hear what are the audiences struggling with, what are they understanding, how can this tool be improved, and then we feed that back to our development of Science on a Sphere, how we make the content that's shown on the Sphere so that we can improve that feedback loop. So here's just a few themes of workshops that we've had in the last few years. We started having themes in 2012. Before that, the theme was, what the hell do we do with this thing? And so you can see many of the same themes that we've been talking about here at this conference with storytelling, how to talk about the Anthropocene, which was the Science Museum of Minnesota hosted, meeting. The big ideas, I was a little frightened by Eric's presentation because the Cole group used the 4 big things, and I was like, oh my gosh, we used a very similar theme for one of our Science on a Sphere workshops. Anyway, we also have collected evaluations. We've had a big emphasis on evaluation from the get-go. We funded a lot of, I should say, NOAA supported the installation of about 16 Science on a Sphere sites in the early days, and then since then, we don't support installations financially. The spheres are purchased by the institutions themselves. We also supported the evaluation of some of our early exhibits, and so when we supported those evaluations, we asked the institutions to submit the evaluation reports back to us, and we've made all of those evaluation reports available on our website. So we have 55 evaluation reports from the various institutions. And then we also have a regularly occurring education forum, which Hillary Petticord manages, and that's another way that we keep up to date on here's a new data set, here's a new way you might talk about that data set, and other things that are coming out with new technology. So now I'm going to spend the rest of my time talking about that one bolded bullet, which is the summative evaluation, which we did with Kate Haley Goldman a few years ago. And basically what we did was we identified Science on a Sphere sites, 16 different ones, that were using the sphere in different ways in different topics, to cover different topics. And Kate and her team trained educators at those sites to conduct interviews with visitors of the sphere to get a sense of the range and nature of impacts that Science on a Sphere was having. So what I'm going to be talking about for the next few minutes are the findings from that, as well as findings we've gathered just from the work of our network over the last few years. So if you can listen to me as this, I hope, plays. So what we learned was that 82% of visitors stated that seeing the information on the sphere changed how they understood the information. You can watch this video on the Science on a Sphere catalog. And I think one of the things that's inherently powerful about Science on a Sphere, it is both an object and a visualization platform. And there's something inherent about the fact that it is a physical object sitting in front of you, and that object matches the visualizations that we're showing on it. There is something incredibly powerful about that. Over a third of visitors stated that it was the realism of the data, and they also talked about how it helped them visualize specific events like this tsunami, and they also commented on how it helped them understand aspects of time and scale. Another finding from our work as a network is that humans learn from other humans. What a surprise. Facilitation correlates with learning. 87% of the visitors who had a facilitated sphere experience, meaning a human was standing in front of the sphere, talking about what they were seeing on the sphere, stated they learned something new. We know that time spent with the exhibit dramatically increases with a facilitator. And interpreters can weave that storytelling that we were talking about in the previous session. They can add context, they can localize the information, they can make meaning with the audience when they can interact directly with the audience. The problem is it's difficult to maintain this capacity. So we've done a lot of experimentation. I can talk to you about that offline on how to train docents on a regular basis. The other thing that we've learned a lot, and we've heard about this in the conference, is that false-colored visualizations are really difficult for general audiences to understand. On the left, you see a typical visualization that would come out of one of our scientists. This is from the global forecast model showing global precipitation using that classic rainbow or jet color map. This is not well understood by visitors when you put it out in front of. It's a dynamic visualization showing future global precipitation. And so we reworked that visualization to the one you see on the right, which has a simplified color scale, has a more recognizable background map, and we find that there is a dramatic change in how quickly people grasp what they're looking at and the meaning of what they're looking at with the visualization on the right. Finally, we need to connect to values. This is back to that storytelling and direct engagement that we have heard about earlier. This picture is from work that we did where we realized you can take a flat map, have students draw their own story on the flat map, and then we take a picture of the flat map, and boom, we can get it up on Science on a Sphere. That kind of direct engagement really, really helps people make meaning and helps them tell their own stories. So we need to do more of that user-generated content, direct engagement. And yesterday you got to see Science on a Sphere Explorer that Hillary showed. So this is basically taking all of the value that we've learned with the big physical sphere and translating that into a flat screen version. So we have a sort of program that you can show on a desktop, and now we're working on a mobile version. So soon Science on a Sphere will be available on your phone for everyone for free. We also have a VR interface for it that is a new experiment. I don't think you brought the VR yesterday, right, Hillary? But so we're experimenting with these other modes of using Science on a Sphere. And I'll wrap up. Thanks a lot.